Hi, thanks for joining this session, The Next Generation Architecture, Unlocking the Power of Your Data. My name is Mohammed Haji. I'm an author of multiple IEEE papers, journals, and co-author of several books. And today we'll talk about why there is a need to change the existing systems to be able to adapt to the modernized way of us handling data. So if you look into this, into the next slide, if you look into here, what you'll see is that we are changing quite rapidly. Things are happening around us quite in a significant way. I mean, for example, did you know we generate 2.5 quadrillion bytes of data a day? Did you know Facebook generates 4.3 billion Facebook posts daily? This type of data and velocity of data that requires a fundamental change to architectures, the architectures that we're very familiar with, because what you require within this is to be able to adapt to the environment, to be able to actually harness the business needs and be able to actually adjust to the customer demands. If you're unable to actually do that, you're unable to actually survive. And many you've seen many in the past that weren't able to actually harness the business requirements, and they never survived those particular trends where customers evolve quite rapidly in their needs. So if you see here, what the biggest challenge that we're facing in the existing way we live is that people would like to have very personalized information, feature rich, very fast, be able to actually operate anywhere, whether you have network connectivity or no network connectivity at any time. These are very fundamental core aspects, personalization, and being able to actually operate online or offline and anywhere. Being able to actually harness these capabilities would actually bring your customers' loyalty quite strong. Those who are unable to actually personalize the information or the applications to their end users, usually you'll see a trend where customers will look elsewhere, because people are quite aligned to things they are very familiar with. So for example, if I load my application, it would require particular functionality and feature, and I do not want to have to set that up every time I log in. And more importantly now, with the ability to be able to actually operate whether you have network connectivity, an application that is unable to actually operate without network connectivity becomes redundant. So you want that capability whether you're online or offline. And you see here the biggest challenge that we have is massively interacting systems. We see millions of operations a second. Customers require, for example, in a particular application, that's not to say, generally speaking, there's billions and trillions of operations happening per second, but certain applications would require, for example, 12 million operations a second. And I've seen that quite a lot. These are not staggering statistics, but how do you handle that? Where you have a legacy system where it's designed on principles that were developed, for example, the data fabric was developed in the 60s and 70s, where things were completely different. And because of that, the legacy, we use that legacy constantly with us. So for example, in databases, if you look at that, they have very traditional normalization of data. And even now, 30 years moving on from there, we still use those fundamental principles. So we need to actually revisit that and understand what we need to do to be able to actually embrace the way applications are used by end users. So what you see here, the biggest challenge that we're facing here is that you have lots of different components. You have a component that does the caching for you. You have a component that does the machine learning. You have a component that does indexing, searching, key value, etc. And the biggest challenge that we face in traditional systems is I require particular components, and what you'll do, you'll add a technology, you'll introduce that technology to that architecture, and then what happens, what you end up doing, you're sellotaping one component on top of the other component. Now, the biggest challenge that you have 5 years down the line, or a business requirement requires you to actually change, then you have to factor in all these different components, the actual caching mechanism, your indexing, your query, and they have different APIs. That becomes a very, very difficult and tedious challenge. And what you would want is the ability to say, well, I have an application that requires these components. I'm able to plug and play. I'm able to actually have all these services in one, be user coherent and consistent APIs throughout. And to be able to do that is a holy grail. This is a very important component to be able to actually achieve all these components in one ecosystem. And also, just to actually recap before we go into the actual architecture aspects of things, as you pointed out before, the schema is quite a challenging aspect because of legacy systems where they have all these rigorous components of normalization, etc. Inability to scale. So certain applications or certain systems or architecture will say to you, yep, you have to have a prerequisite of all your requirements up front. Now, in this modern world, you'll have a burst of activities. You want to be able to scale. You want to be able to actually harness that. We've had multiple, and I've seen multiple use cases where they'll say to us, we have a data set, we know that data set, but all of a sudden they have an influx of data because the application becomes so successful. And because of their success, they're unable to actually embrace that because they're unable to actually scale out. So you need a mechanism where you're able to scale out. Performance is also important in the sense if you're able to scale and you have a flexible data model, but you're unable to actually handle the number of operations, then it becomes a problem for you. And on top of that, even if you achieve the actual flexible data model, ability to scale and the performance, the core aspect of everything is the cost. You need to make sure that whatever architecture you produce at the end, there is a cost saving to it. So if you look at here, in an ideal world, what you would require is, as you pointed out, all these different services under one roof. The mobile aspect, the querying, the index, the services, the caching, etc. And as I pointed out, I've seen many different architectures, particularly practically, I can say hundreds of thousands of different architectures when it comes to this, where they have lots of different components. And the biggest challenge is when a business requirement asks them to do something, it's very difficult for them to change. So what you would want is an ecosystem that handles all these components as one. So, okay, we talked about that. We talked about having an ecosystem that handles all that. But what is it about scalability? What do we want within this? So as we said, we have an architecture, you have a particular set of nodes, but all of a sudden you have a burst of activities. For example, I remember helping a particular end user for a requirement, and what they wanted is the ability that at the moment a request comes along, they're able to actually scale out that data set and be able to actually harness it quite dramatically. But what was happening is that they had a massive infrastructure, a legacy system that was holding them back. Now, the problem that they were facing is that the end user said to them, you need to be able to actually provide a service for our subscriptions in the sense we paid a particular subscription. If you're unable to actually service us at that peak time and your applications and consequently infrastructure is crippling, then we'll pull out. So it was a requirement from the actual end users of the business, you need to actually change and modernize to be able to actually handle the peak load. So what you would want is the ability to actually burst out. The moment you see a trend in your traffic increasing, you want to be able to burst that quite rapidly. What you see here also, having the ability to burst out also requires you to actually have the mechanism to self-heal. So not only being able to actually burst out, but having that mechanism to say, if a particular node fails in my architecture, I'm able to self-heal. That's a quite important thing, not only scaling out, but also self-healing. And on top of that, so you have an infrastructure where you scale out, etc. But what's very important, and a lot of architectures miss this component out, is the ability to have this multidimensional scaling. What do we mean by this? If you look at traditional systems, there have multiple different services stacked up on one particular hardware. And the challenge that you face with that is that you get into components where there's a contention of resources. One resource would require CPU utilization, while the other requires IO ops, etc. And then if you have a burst of activities, your application becomes a burden to the end user in the sense of unable to actually handle that request. What you would want, for example, is you can say, well, in my development environment, I'll have everything stacked up because it's not in the product. In my dev environment, in my QA, I can have these different services. But what you would want in the end product is the ability to say to yourself, well, I have different hardwares that have different capabilities. For example, have hardware that has high CPU capabilities in the sense of a lot of cores, while other hardwares or other servers and their components will have very good SSDs and RAM. And then you have what you want to do, you want to slice and dice those different servers based on your requirements. So the core aspect here is not to have all your services collated and stacked up on one particular server. You want to slice and dice based on that. Now, having said that, that leads us to another component, a very key component, is the microservices strategy. Every new architecture that's developed now is moving to that microservice architecture. What do we mean by this? Well, it allows you to embrace innovation and be able to actually introduce that quite dramatically and quite based on the business needs. So for example, here, if you look at the legacy systems you pointed out, you have all the different components stacked up. You have your analytics, you have your basically your caching, your data fabric, your eventing, all those stacked up. And the problem is, what you want to do, you want to actually break that down into small fragments. You have an application that deals with stock control, you have a different application that deals with pricing, a different application that deals with advertisement, and you want to actually isolate. And the reason for isolating this is that you can have different applications moving in parallel quite rapidly. Now, if, for example, the actual pricing teams are held back because of the advertisement, or the stock control is held back because there's a particular feature that they need to use, it doesn't bring the entire application to a halt. All these different applications and development teams can run in parallel and be able to achieve that. So in the legacy system, everything had to be done in sync before you can go to deployment. Here, you're able to actually say, well, I have this component and I'm able to actually move to the next level. I have this component, I'm able to move to the next level and not be tied into the entire infrastructure as a whole. So what you also require is that you have the ability to actually scale out. You have the ability to slice and dice your infrastructures based on your requirements. But what's more important is the replication capability. Now, here is quite a very, very fundamental aspect here, where you want to be able to do a number of things. You have on-premise, in the sense you're able to actually push your data out. If a mutation happens in one data center, you're able to push it into different data centers. In the sense, for example, what we see, especially in the FX industry, where they have a particular requirement, they need to be able to have, or be able to survive a particular data center going offline, and not only that, but also have an entire data center in a different region and a completely different geolocation altogether. So what we see here is the requirement to be able to actually, any mutation that happens in one data center, you're able to push it out across the different data center. In this a diagram that we have here is that you have data centers, for example, the US, in London, and for example, in Singapore. And here it's like follow the sun, in the sense you are able to actually operate in London, that data is pushed into the US, and then that also is simultaneously pushed into the Far East. And anything that happens, any mutation that happens, you're able to see that seamlessly across the different regions, the different data centers. And on top of that, what you also want is not only the particular hardware to be able to actually push and replicate the data, but for example, if you don't have hardware, you want to be able to also push it to the cloud. So for example, if I have data that I can see there's a peak load of operation, and I want to actually burst to the cloud, so I don't have to wait for my hardware or the provision hardware, I'm able to actually push my data or my application to the cloud. So that burst of activities, you're able to actually harness that. So it's quite important not only to replicate your data within a cluster, but also replicate it across different geolocations, and also have the ability to burst to the cloud. That's quite a key important component. So if also for here, another aspect is having the replication capability is great. But the other aspect, the most key aspect of all, is to say, well, if our data center goes offline and my application is programmed to read from that data center, I need the ability to automatically self-heal, automatically flip my data from data center 1 to data center 2. That shouldn't be a manual process. That should be an automated process, and it should be a self-healing process and multiple Ways of looking at this is the multi-cluster awareness, where you have your APIs being able to actually understand that a particular data center has no longer now in operation, or certain thresholds or certain areas of breach. I will switch my entire traffic to data center 2. And that's quite a key component to be able to actually do that, is the ability to switch from data center 1 to data center 2, or even data center 3, depending on your requirement, because you do not want any downtime. And that's quite an important thing. So you'll see multiple architects saying we can do the replication, but the next component you need to ask, are you able to self-heal if a data center goes offline? Are you able to actually do that? So also on top of this, so you have all these new developments in the sense scalability, multidimensional scaling, but more importantly is the ability to say to yourself, I need a component or I need APIs that are not going to be a massive burden to the developers. Because the traditional approach is, why reinvent the wheel? What we want to be able to do, for example, is you want to be able to query data. So multiple modern architectures are going down the NoSQL approach, but the challenge that they bring with them is a new complete set of APIs. This is a burden to the developers because there's another layer of complexity where you have to learn and be able to understand the data set, etc. What you want to be able to do is embrace the new ways of architecting and developing things, but at the same time use those skill sets that you already have to be able to actually allow you to actually adapt and adopt to these new technologies quite rapidly. So what you see here is you see a component where you're able to actually develop your actual querying capability based on traditional standards, and that's a key component in any new ways of developing things, whether it's an architecture or development, is that you need to be able to actually embrace the skill sets you already have. And many technologies have failed where they came and reinvented the wheel. So that's a key component of what I've seen in the field multiple times. What you see here also on top of this is that we've showed modern architectures where you're able to scale out, where you're able to slice and dice your data, where you're able to actually have that capability to actually perform the SLAs, the performance that you require from the application. But on top of that is, what are you going to do with that data set? As I pointed out right at the beginning, we generate 25 quadrillion bytes a day, which is a phenomenal amount of data. So you need to be able to actually extract the relevant information from that. What we see in traditional systems has become a very big challenge, especially as the volumes of data increases on a daily basis, is the process to be able to say you have the operational data, and then on top of that, the traditional systems, once they have the operational data, they overwait for overnight batch processing. They take that data, basically cleanse that data, ETL, extract, transform, store, and then pushes it back to the analytics. That is a very slow approach, because by the time you've done all the analytics, the actual information is no longer relevant. 24 hours, 48 hours is no longer relevant. If someone's on your website, does a particular purchase, you want to be able to understand what is purchased and be able to cross-sell and upsell. So what you would want to be able to do is to be able to have the ability where you're able to actually, the moment an operation comes in, you're able to process that and be able to actually process that in real time. So as data comes in, you're able to process that and not wait for ETLs or batch processing, and then provide that answer straight away to the business. And that's a key component. So even though you have all these modern ways of developing it, the key thing, as we pointed out before, yes, hold on to the actual traditional APIs that have been successful, but in stuff where it has become a burden to the architecture, such as the actual batch processing, you want to eradicate that. And one way to be able to do that is to collapse the components and be able to process that in real time. And that gives you the competitive edge. And if you look into here, what you require is, you say our data fabric is quite important, but also at the same time, what do I want to do with that data fabric? You want to make a copy of that data so you don't basically affect your core basically system of record. And once you want to do that, you want to have this massive parallel processing power. So once you've done that, you need to actually introduce these components where you're able to process that quite rapidly. And then on top of that, you're able to slice and dice and extract the data that you'd want. And that's quite a key component. And that's what most I've seen in the field, where what they will do, they'll make a copy of the data, do a lot of multi-processing or massive parallel processing algorithms on top of that, and then extract the data that you'd want. And then on top of that, with that type of ability, you're able to actually visualize that data. At the end of the day, that's what you would want to be able to do, is visualize that data. The other thing, the most important thing, as I mentioned, lots of important things, but in modern ways of developing architecture is quite important, is the edge and basically IoT devices. Here, what you would want is not only have your data fabric, but you will want a mechanism where you're able to actually push your data to the edge and be able to actually work offline and online. And the key component here is the secret behind this is the synchronization, is the ability to be able to sync between your devices and your end basically data fabric, is the ability to actually push data in, be able to process it and then push it back out. And then also, if there's any mutations on different devices, to be able to actually have that mechanism, synchronizing mechanism of being able to resolve conflict resolution and then pushing it to the back end devices, for example, your data fabric, or to the edge devices where you want to actually, or where the data is being picked up. And this is quite good for logistics, for parcel deliveries, field operations, etc., etc. So anything where you have components where they want to work offline, this is very important, basically having that central core where it's able to coordinate and synchronize and resolve conflicts within this. And I would like to actually take this opportunity to thank everyone that has joined this session. Hopefully you found it useful. There's quite a lot to take in. Being able to actually look at the traditional systems, take the best of breeds and provide that into the modern way of thinking, where things need to happen instantaneously, gratifications needs to be provided instantaneously, and the volumes of data that we've generated is quite significant. So it's quite important to actually learn from our past, adopt the actual best practices and principles, and harness and provide that custom experience that everyone is looking to actually achieve. Hopefully you found this useful, and I'm very grateful for you to actually have listened to this talk. Thank you very much.